Is this thing on? Well, guys, you made it. Congratulations. Give yourselves a round of applause. I have the misfortune of being the last speaker today. And this is a lightning round, so it's going to go very, very quick. Try to do about 20 minutes and hopefully leave time for a couple of questions. Luckily, I think this is the crowd that is the most dedicated, so I'm expecting good questions. As a little kind of warm-up to get ourselves woken up, can I ask everyone to pull out your phones, please? Okay, find the number that you last called and try to memorize that number. I'm going to give you 5 seconds. Okay, please put the phones away. Do you remember what the time was? Why not? It was right in front of you on the same screen that you were staring at for 5 seconds. This is a little cute example, but it's a demonstration of a much larger force in our lives, which is that essentially it's a very kind of cutesy demonstration of the stuff that behavioral economics deals with on a daily basis, which is that humans are much less independent in thought than we would like to believe. And the mechanism we just explored is the fact that there are sort of limited capacity constraints on our attention span in any given moment, right? If you're focusing on something very intensely, then anything else that you, although see in your field of vision quite prominently, can be left out of your actual processing. And as I'll talk about in a minute, this has massive implications for what we do on a daily basis. So what I'm trying to do here is threefold. Yes, sorry. Swear I've done this before. So I'm trying to do a couple of things here. By virtue of who I am and what I'm trying to say, I have to give a very brief introduction as to what behavioral economics and behavioral science is. But more generally, I'm trying to kind of wrap up today's discussions with this idea of like how do you put the AI modeling process in the context that it's actually used in most organizations, or at least the type of organizations that I have experience working with. So the idea here being, AI does not stand alone, and it needs to integrate with a lot of processes that are mostly thought of as kind of research questions or perhaps social science. And hopefully I'm going to try to lay out a very brief framework for how that can be possible and why we should try. And finish up with a couple of examples. Okay, so this statement should be self-evident. Intention does not always lead to action. Our lives are full of examples where we have a great intention and our actual actions, quite possibly a little bit later in the future, do not match up, right? Eating healthy, going to the gym, saving money, many, many others. I used to do this presentation with putting on a condom, but apparently that's controversial. So yeah, many cases where intention and what we know to be the right behavior does not match our actual actions. Now, why is that? Is that because we're fools? No, we are time inconsistent and we're limited or we're influenced by forces around us. What are these forces? Well, you can bucket them into a few major kind of categories. Our environment, generally what else is on the screen, kind of. The influence of our social group, cognitive constraints on our both motivation and our memory and focus. But the kind of key insight here is that these patterns or these limitations are very predictable. Dan Ariely, who's a famous behavioral economist and kind of created the term for all intents and purposes, wrote a book called Predictably Irrational. That is, human beings deviate from what they want to do, but in predictable ways. And let's see how we can exploit that. So this is the memory example. I'm going to give you one more kind of cutesy example of this phenomenon at work. I'm wondering if our colleagues here could play this video. The technology of the 22nd century. We're here. Tumefika.
In the elevator now.
Is it a YouTube link?
It is a YouTube link. Is that a problem? Sorry.
Can you push it, please? Website? This website?
Maybe in pursuit of lightning fast, we can finish with this. If you guys can pull up the link in a separate.
Yeah, fine.
Okay, sure. So we'll talk about that in a second. Okay, so I'm talking about the ways in which human beings can be understood as having predictably irrational responses to some stimuli.
One second.
No problem.
Yeah, it's coming.
Is a candid star. These folks who are entering, the man with a white shirt, the lady with a trench coat, and subsequently one other member of our staff.
This clip is from the 1960s. I apologize for.
And you'll see how this man in the trench coat tries to maintain his individuality, but little by little, he looks at his watch, but he's really making an excuse for turning just a little bit more to the wall. Now we try it once again. Here's the candid subject. Here comes the candid count staff, 3 of them at least. And this man has apparently been in groups before. Now, here's a fella with his hat on in the elevator. First he makes a full turn to the rear and Charlie closes the door. A moment later, we'll open the door, everybody's changed positions. Now let's see if we can use group pressure for some good. Now, in a moment, on Charlie's signal, everybody turns forward. Notice they take off their hats. And now, do you think we could reverse the procedure? Watch.
Right. So that's hilarious, but not particularly surprising to anyone, I think, right? That human beings are extremely influenced by the subtle cues of people around us, by examples that we see. And so what my organization does, the Busara Center for Behavioral Economics, is sort of tries to apply these principles to help organizations sort of solve their problems in market access and consumer understanding in the global south broadly, mostly in sub-Saharan Africa. And the reason that sort of why this is different, I suppose, is something I call the weird problem, right? This acronym, Western, educated, industrialized, rich, and democratic, is a group of adjectives which describes countries that constitute 12% of the world's population, approximately, but that constitute 96% of the research subjects in psychology and experimental social sciences, right? Just to drive this point home, here's a map of the world scaled by population, right? So some countries, Russia and Canada, a lot smaller, India is a lot bigger, but generally the shape of the world is more or less what we're used to seeing. And here's a map of the world scaled to published research in those fields, right? So Europe is huge, and Africa between the Sahara and South Africa shrinks to a point, right? So there's a huge need, I think, for organizations and researchers to, when they're trying to do science, which is described as universal, as psychology is, to get a representative sample of the world's population. And this is obviously a form of the type of bias that Alfred was talking about so many hours ago. Okay, so let's bring it back to AI while we all are here. So this approach seems, well, let me just make a remark first. So what I'm saying is that, you can, through research, experimentation into how people behave, discover patterns of irrationality, biases, etc., that are consistent, and you can use these to develop interventions or to help companies reach markets, etc. But all of that seems kind of diametrically opposed to what AI is, right? So the big innovation, of AI in maybe the last generation is this kind of redefinition of the problem statement in a lot of fields. So take Google Translate for an example. It is impossible, essentially, to make, no matter how skilled you are in both languages, no matter how intelligent you are, and how long you work at it, it's basically impossible to make a rules-based system to translate Finnish to Japanese, right? The languages are too complicated, the context too varied, right? It's almost a laughable endeavor to try it. People have, actually, but not those two specific languages, but in general. But that is basically impossible, right? The way Google Translate was able to revolutionize this field was by redefining the problem statement from a rules-based if-else sort of system to a statistical system, right? In that if you can get the right set of data, the right texts, where both languages are side by side, and the right algorithm, you can actually solve this problem without actually knowing Finnish or Japanese. And as a matter of fact, it's remarkably successful, right? And it's getting better with time. I mean, Google Translate is just still blows my mind. So again, so AI in its most remarkable achievements has sort of pushed out the idea that you need to understand how the human brain works or how necessarily the system works and just pick the right model and the right data. But let's skip this slide. But that 1111. Oops. But that, in real life, in context, cannot be enough for a lot of the applications that we deal with, right? And there's sort of 4 reasons I identify why. One, that a great prediction model is not necessarily, so a great prediction model is not necessarily worth much if the people who are in the position to make the decision to implement it don't trust the system, right? So we see that with a lot of banks here in Kenya, where, I mean, they'll have the capacity for, kind of fully optimizing a lot of their back-end, the credit systems and so on. But we'll see that their risk committees won't buy in, won't let them sort of take over the entire lending process with an algorithm, because there's not, there's kind of a lack of understanding of how the system works. Relatedly, an algorithm, and I'll say this in kind of technical terms and then explain what I mean later, an algorithm no algorithm is trained on a data set that encompasses the full sample space. What I mean by that is there is no algorithm in the world that knows anything outside the data it's been trained on. So this can be as prosaic as, a loan algorithm cannot tell you what happens no matter how much it's regularized if the loan product itself changes. Sort of more, a little bit more seriously, last year a woman in Arizona in the US became the first person to be killed by an autonomous vehicle, right? And the situation, broadly speaking, from what's been what I've read since, is that a woman had a shopping cart and was crossing the road at night. She may have been a homeless woman. And an autonomous vehicle, which was a Volvo driving for Uber, saw the individual and for some reason sped up. Now what's remarkable here is not necessarily that the machine did that, but that it was almost impossible to understand why, right? Because when you have that many, that level of complexity in your algorithms running on that large a data set, right, and constantly updating, it's almost impossible. The black box becomes so opaque that it's almost impossible to understand how that decision was actually made by the machine. And so, you have a position where you need a little bit of transparency in how these sort of particular prediction cases are actually made. Understanding the data generating process is critical. So, this has been referenced several times over the course of this session. In particular, I want to draw attention to some work that was done by the AI lab at Makerere University in Uganda. So they have a very interesting project of trying to do some traffic analysis, so of traffic prediction in Kampala, where they're based. Hurry up. What they found is that traffic is usually modeled as kind of like as a discrete process, right? Or in terms of necessarily like vehicles per road per hour, right? Or per stretch per hour throughput. Makerere's big innovation was that they realized that doesn't really work for African roads, as anyone who lives here can tell you. So they had to monitor, had to model roads in Kampala instead of that way, basically the same way that you would model a river, as something that can swell and narrow depending on the time, but has no kind of discrete identifiable units as part of it. And lastly, there are a lot of sort of ethical considerations to bring in. So that's me kind of trashing AI, but this is ways in which there is room for kind of traditional research sources and social science. Let me hurry up with this. So a simple framework for thinking about this is that a data model building process has a data input and has a decision support output. That is both an algorithm and the tools to apply that algorithm, as well as maybe to understand it. In between, there's an iterative cycle of causal understanding, and that's maybe A/B testing, that's maybe visualization and sort of descriptive analytics, as well as the model building itself. So let me hurry up and give you two cases where this type of process can be engaged. Okay, so a lot of machine learning applications in business settings can be described as predictive targeting or just targeting, right? And so this is very frequently done on which people, right? Which people to loan to, et cetera. But with new data sources and with some understanding, we can also think about for each individual what the right time is to provide something. So the use case I want here, or I want to describe here, is a research project that we have regarding, or a set of research projects that we have about phone sensing. So this may be kind of old news to all the developers in the room, but your smartphone has a vast array of probes, broadcast receivers in technical language, which record basically all attributes of the stuff the phone is doing and the way that you're interacting with it, right? So that's things you think about, like your communications, your app usage, etc., and also things you don't, right? or things you don't in terms of accelerometer. How fast is the phone jiggling? Like the location, how many times you turn it on and off, whether a phone is charging at a particular time. And this is for us, is a quiet data revolution in that there are these reams of high quality data that are produced naturally that are fairly accessible with the right incentives for people to share them with you, and can be used for massive predictive analytics. So this is the way that Branch and Tala work in particular. Is basically they have no credit history on you, but you download their app, you give them permissions to everything, they scrape everything, they have a good model to predict creditworthiness, right? So this stuff alone can be used there. We are trying to use this data sources in the research project to target behavioral interventions. So as I believe it was Georgina from MPK was saying, imagine as we learned before, people don't save as much as they want to. A big part of that is timing consistency. So if you could target people at the right time with prompts to save, you could theoretically really increase people's well-being over the long term. Now, this is easy if you have a bank and people are getting paid by direct deposits. With this, from scraping M-Pesa messages and from sort of update messages from banks, you can figure out with relatively good accuracy when people are going to get large sums of money coming in, and tailor, specific messaging to them. Say, why don't you save 10% of this month? You've always wanted to. And so some other application. I mean, obviously this technology is not new, has a lot of applications, but we find that you can combine it with sort of traditional like behavioral programs in finance or in policy making, make them more effective. A second sort of common use case comes in market research from behavioral segmentation. So behavioral segmentation is typically using behavioral measures that you think are useful to then segment the market in a machine learning framework. So a typical approach would be psychometric, take a subset of your customers, try to use psychometric measures on that subset, then use a sort of unsupervised like k-means clustering algorithm or other clustering algorithm, train that, and see if then the groups that come out you can learn something about by bringing it back into the qualitative behavioral social science research approach. And it's where it can be remarkably effective. One recent project where we found this to be very useful was Busara was commissioned. So DPV rings are vaginal rings similar to the ones commonly used for birth control. But instead of using birth control, they are to prevent HIV, to prevent contraction of HIV. And so this is a technology which has, sort of massive potential over the long term to improve health outcomes. But most women's kind of reaction when they hear about this is kind of like, And this is a problem where social science can maybe try to reframe people's thinking about this. So what we did here is we took a survey of 300 women in both Malawi and South Africa. We asked them both basic demographic questions as well as a set of psychometric questions that we felt were probably predictive of uptake of this, such as what do you think the subjective risk is of getting HIV, sexual partners, questions about how influenced they are. 2 seconds. You throw this into a k-means algorithm, and after sort of tuning and looking at the data, you come up with 4 clusters, 2 of which are very high adopter, high probability of adoption, 2 of which have very low probability of adoption. And so what you see here is that these measures allow you to bifurcate kind of groups and then treat all of these groups differently. So you give up, the researcher gives up control over who the targeted segments are to a ML process. And then, sort of targets each of those separately. Okay, one last thing. So where does this kind of thinking lead to? Well, it leads to what we might call decision engines, which is that imagine you can, and versions of this exist in different settings, but imagine you can integrate a full cycle of research from kind of predicting an outcome, then predicting correct intervention, implementing that like intervention or recommendation, updating the model, and repeating the process in the productionalized framework. And so you can see, the big thing here especially is the second step, which is that, what is the right thing for this person to get to intervene on this outcome? Not just what will maximize, what is the maximum possible Y for them. And you can imagine sort of like, maybe like a genetic-based model in which you kind of constantly iterate on your recommendations, your messages, and find the maximum. So we're looking at projects that do this in the financial space. So predictive default for a loan product, generate and deliver a message, update the recommendations. Sorry, that wasn't so lightning, but yeah, I hope it was a stroke of genius. Okay, thank you.